Hey, what's up, guys? So today, I want to prove results that usually mentioned in the logic gate. So let's go back to high school. But the undergraduate and started electronics. Okay, so logic gate has two results that basically I want to prove here is that the AND gate, NAND gate, and the NOR gate are universal. Gate. Or one another statement, if you're more familiar with logic, that people will say that NAND gate and the NOR gate are functionally universal. Some people say functionally complete. Okay, so let me quickly describe. Okay, so idea is that if you start from 0, 1, with the bit string 0, 1 with length n to the 0, 1, this is so-called a Boolean function. This is called Boolean function. And the very simple fact is that any Boolean function, so any bool function can be made by and or not. Okay, so let me just quickly review some basic idea or and not. Okay. So if you, let's say this is A and B, if you put A to be 0, then not A will be 1, right? And then 1 and 0. Okay, so this is 0, 0, 0, 0, 1, 1, 1. So let's quickly review. So AND gate means that everything need to be AND. So it's 0, 0, 0, 1. Okay, so in a logic language, people like to write A, B, and the OR gate, people like to write A plus B. Okay, so this is 0, 1, 1, 1. Okay. And then where the NAND gate, in the logic gates, people write it as this. Okay, so this straight means that the AND and the NOT is here. Okay, so NAND gate means that you reverse AND. So we are 1, 0, 0, 0, and the so-called NOR gate. Okay, so NOR gate is 1, 0, 0, 0. Sorry, this is stupid. NAND gate is here. Okay, so I think this is very concise introduction. Okay, so now let's quickly give the proof that the NAND gates and the NOR gates are basically universal. Okay, so theorem NAND gates is universal. Okay, so what it means is that you can, so basically one can form AND from NAND, and one can form OR from NAND, the NOT from NAND. Okay, so this is the standard the proof. Okay, so let's quickly prove it. So the only non-trivial part is this one. Okay, which looks actually trivial. Okay, so if you see this, that you will see that when A is 0, then the NAND is 1, right? Because if you put 0, I mean, if you put 0 and 1, and then you put 1, 0, which give you, yeah, okay, so if you put A to be 0 and then not B to be, let's maybe see, let's maybe do this. Oh, so let's see this. So this is NAND. Let's say this is A, right? Okay, so I want to create NOT by using NAND. Okay, so how do I do this? Okay, so I want to create NOT gate using NAND, right? So who should I see that if I put 0, 0, I get 1, right? If I put 1, 1, I get 0, right? So this is very trivial, right? I just put and A, right? I put the same A into this NAND gate. Okay, so this will give me NOT. Okay, so from you can see from this diagram that if A is 0, B if both are 0, then give me 1. If both are 0, if both are 1, which gives you 0. Okay, so this is, I create this. Now I can trivially prove this AND from NAND, because AND is just the NAND, there is a NOT, right? I just add NOT, or basically I can write A and B. Basically, it's not, right? Not, right? So this is NAND gate. And by these results that I already create NOT gate, right? So I just apply another NOT. Okay, so this is use the NOT gate. Okay, so I can prove this. Now final is a NOR gate. Sorry, the OR gate. Okay, so OR gate. And this is also trivial using the famous De Morgan. This is very famous. That De Morgan is trivial theorem, but looks so powerful that everybody like it. Okay. So I want to create this, right? So that's A or B. I can write this A or B, not, right? I can create not, right? But now using De Morgan. So De Morgan give me and then a not and a B, right? Okay, so this is not A and not B, which I already create not, and I can create a AND gate by the previous theorem, right? Because I can NAND gate. Okay, so this is a NOT gate. So I can create an OR gate using the NOT A, NOT B, and AND gate and NOT gate, which I already created NOT gate and AND gate from the previous proof. Okay, so yeah, so which prove that NAND gate is universal. Okay. Okay, so theorem. Now let's prove another results. NOR gate is universal. Okay, so I think you can see this, right? So if both are the same, 0, this equals 0. If this 1, right, it gives you 0. Okay, so this proof is actually exactly the same. Okay, so first we notice that we first noticed that the AND gate, sorry, NOT gate is trivial, right? Because so I think this is NOR gate. So or usually people use the curve one and the dot. So this is put in, right? Let's say this is A, and this will give you not A. Okay. Now I can create the OR gate, right? Because OR gate is the NOR gate and add a NOT. Okay, so A or B will be A NOR B. So I can create a NOR gate and create a NOT. Okay, so and the NOR gate is available and the NOT gate is already created here. Okay, so this is so trivial. Finally, I want to create an AND gate. So proof is trivial using the same thing, using the same technique, which is De Morgan. So I want to create A dot B, and I can write this A dot B not NOT, and I use the NOT to be using the De Morgan. Okay, so this is AND gate, and but this is not A, not B, and OR, and NOT. So I can create an AND gate using OR gate, NOT gate, and the NOT gate, and the NOT gate. Okay, so which I already create OR gate. Okay, so which prove that NOR gate is universal. Okay, so I think this is this very quick introduction to the logic gate, and I think you already know everything. Okay, see you guys next videos.